In manufacturing, when something goes wrong, like repetitive defects or sudden process failures, everyone asks the same question: why it happens? But guessing won't solve the problem. We need a structured way to find the correct root cause. That's where the cause and effect diagram, also called the Fishbone or Ishikawa diagram, comes in. This simple and powerful tool helps quality engineers to visually see every possible cause of a problem. By the end of this lesson, you'll know exactly how to create, interpret, and use a cause and effect diagram to solve real manufacturing problems. So, what exactly is a cause and effect diagram? Think of it like the skeleton of a fish. The head of the fish represents your problem, the effect you're facing on the shop floor. The bone branches from the spine shows categories of possible causes. This tool was developed by Dr. Kaoru Ishikawa in the 1960s and is now one of the 7 QC tools used worldwide for quality improvement. It's not just a diagram, it's a thinking method that ensures we don't jump to conclusions. Instead, we investigate causes from every angle using a structured visual approach. Let's take a practical example from automotive manufacturing. Imagine you're in the assembly line and your team is facing frequent part damage issues. Parts are getting scratched or dented during handling and also received customer complaints. To solve the problem and its cause, your team decides to use the Fishbone Diagram. At the head of the fish, you write the problem, part damage. Then, with team together, you brainstorm all possible causes using the 6 M categories: man, machine, material, method, measurement, and Mother Nature, also known as environment. Under machine, you might note excess clamp pressure or worn-out tools. Under material, maybe incorrect hardness or bad incoming dimensions. Under method, perhaps improper handling or poor packaging. By the time the team finishes brainstorming, the diagram looks like a full fish skeleton with all potential causes. Now, let's walk through the steps to create your own cause and effect diagram. Step 1. Define the problem. Write a clear, measurable statement like high rejection rate in welding process. Place it inside a box at the right side. That's your fish head. Step 2. Draw the spine. Draw a horizontal arrow pointing to the problem box. This is your backbone. Step 3. Identify major cause categories. For manufacturing, we use the 6M framework: man, machine, material, method, measurement, and environment. Draw 6 diagonal branches from the spine and label them. Step 4. Brainstorm possible causes. Get your cross-functional team together: production, quality, maintenance, and design. List every possible reason under each branch. Use brainstorming. Step 5. Add subcauses. Go one level deeper. For instance, under machine, add improper calibration, worn-out tip, or low pressure, and many more as per brainstorming discussion. Step 6. Analyze and identify root causes. Now, review the full diagram. Look for repeated patterns or data-backed causes. Collect data or conduct small experiments to confirm which causes truly matter. Step 7. Implement corrective actions. Once verified, plan and execute corrective and preventative actions to eliminate or control those causes. Once your diagram is complete, don't stop there. This tool gives you possible causes, not confirmed ones. So your next step is to validate them using tools like cause validation tables or controlled experiments to check which causes truly affect the problem. And once you validate the cause, then you have to find the root cause using 5 why analysis. And asking why to each cause, you get the final root cause. In our earlier part damage example, the team found that the main culprits were worn-out clamps and lack of operator training. Once maintenance and training actions were implemented,
rejections dropped drastically. Now, let's talk about a few common mistakes to avoid. First, don't start without a clearly defined problem statement. Vague problems lead to vague causes. Second, don't confuse symptoms with causes. A scratch on a part is not the cause, it's the result. Third, don't limit brainstorming to just one department. Quality alone can't solve it. You need production, maintenance, and design together. And here are a few expert tips. Always use real data and observations, not opinions. You've just learned how to identify and visualize root causes using the cause and effect diagram, one of the most important QC tools for every quality engineer. In the next lesson, we'll explore all 7 QC tools in detail.